Hello, Math 136 students. This is the midterm review, part 2. We're going to be looking at numbers 14 through 26 to finish up our midterm review. So number 14 is solving an absolute value equation. Now, to solve an absolute value equation, you must first isolate the absolute value on one side by itself. So we're going to subtract over that 14 that is added after the absolute value sign. So that's going to give me 15. We also want to divide the 3 to the other side so that the absolute value is by itself. So we have absolute value of 2x minus 1. Be careful not to make this look like 11 equals 5. Now, once you've isolated your absolute value, if the number on the right side where you're equal to that number is negative, that would be a no solution because you cannot say that absolute value, which measures distance, equals a negative number. Since ours is positive, there's two possibilities for this could have happened. The inside of the absolute value could have been a positive 5 before you took the absolute value symbol, or the inside of the absolute value could have been a negative 5 before that was evaluated. So we set up those two possibilities. The interior is either positive 5 or the interior is either negative 5. So we will add 1 on this first side, which gives us 6. Divide by 2 gives me 3, which I could check if I want to. That'd be 6 minus 1, that's 5. Absolute value of 5 is 5. On this one, we will add 1, which makes this negative 4. Divide by the 2, that gives me negative 2. And negative 2 times 2 is negative 4, minus 1 is negative 5, and the absolute value of negative 5 comes out as a distance of 5 or positive 5. Okay, let's look at number 15. This is a radical equation. Again, isolation of the radical is the first step, so we're going to subtract over the 7 to the other side. So that's going to equal 4. Then we use the power rule to get rid of the square root, which says we can square both sides as long as we realize that this may create extraneous solutions. So that would then be 3x plus 4 equals 16. So if we subtract the 4 over, that's going to be 12. Divide by 3, we have a 4. Because you use the power rule, it is required that you do a check to make sure your solution is a true solution to the original equation and not the one we got once we squared everything. So we put it into the original equation, so 3 times 4 plus 4 under the square root plus 7 equals 11. That would be 12 plus 4 is 16 under the square root plus 7 equals 11. The square root of 16 is 4, and 4 plus 7 does equal 11. So this is the correct solution. Now when we look at number 16, this is a similar situation, except we need to move that 2 away from the radical, so our radical's on the other side. The difference here is that once you've got that isolated and you go to square both sides to get rid of your radical, you're going to be squaring a binomial on the left side. When we square a binomial, we have to write it twice and multiply it out. So this is going to be x minus 2 times x minus 2. On the right side, the square and the square root are opposites of each other, inverses essentially. So that's going to cancel and just leave us the base of x plus 18. We need to FOIL all of this out. So that's x squared minus 2x minus another 2x plus 4 equals x plus 18. Combine like terms on the left. Now, because this is quadratic, we need to get everything to one side. So we're going to subtract the 1x over. That will make this negative 5x. Subtract the 18 over. That's going to make this negative 14 equal to 0. We need factors of negative 14 that make negative 5 when we add them together. So they're opposite signs since they multiply to negative 14. And it'll be x minus 7 and x plus 2 equal to 0. Set each of these equal to 0 to solve for our two possible choices. Now we are not guaranteed that either of these are solutions or that both of them could be. We don't know until we actually try and solve it. So we can put these back into the original. So we're going to do a check for each. So 7 equals 2 plus the square root of 7 plus 18. That is 7 equals 2 plus the square root of 25. The square root of 25 is 5, and 2 plus 5 does equal 7. So we know this one works. Negative 2 equals 2 plus the square root of negative 2 plus 18. That's negative 2 equals 2 plus the square root of 16. The square root of 16 is 4. Negative 2 does not equal 6. So notice the second solution is extraneous. And that is something you will have to check and show, otherwise you will not get the full credit. You need to show your checks. All right, so number 17 can be done one of two ways. You could try factoring it. It's just got higher powers than we're used to seeing. These are those quadratics in disguise. It's kind of, or sometimes they're called quadratic in form, depends on who you ask, but they look very similar because the power in the middle is half of the original power. So just like an x squared and an x would be. And we teach these either by u substitution, or some people just teach it by factoring or quadratic formula. If you use the u substitution method in the book, you let u be the variable piece or the base right here in the middle. So that's just that part, not the coefficient. So that part that was squared in the middle was the x. Then we would let this become a substitution. So if u equals x squared, x to the fourth would be u squared, because it would be 2x squareds multiplied together, so u squared. Minus 15u plus 54 equals 0. So this is called a u substitution. Then we would try to factor in terms of u. So factors of 54, we don't know them, we can list them. 1 and 54, 2 and I believe 27. I believe 3 goes into it. 54 divided by 3, declare my calculator, is 18. So 3 and 18. And that's the pair we need. So I'm going to go ahead and stop. Because, oh, actually, no, it's not. We're not going to stop. See, pay attention. It's not 3 and 18. If it was an opposite, negative 54, 3 and 18 could work, but it's not. See, I caught myself doing the same thing I would have warned you about. If we were subtracting, it would be 3 and 18 because that makes 15, but this is a positive 54, so we need it to not subtract, but add to that. So they're going to be same signs. So 54 divided by 4 does not go evenly. 54 divided by 6 is 9, and that's the pair that we need. There's going to be two negative numbers to multiply to positive 54, but add to negative 15. So we get u minus 6 equals 0, u minus 9 equals 0. Add the 6 over, add the 9 over. Now the problem is we were not originally solving for u, we were solving for x squared. So we need to turn both of these back into x squared. And then to take the x squared and turn it into just x, we take a square root of both sides. Anytime you add a square root in yourself or any even root, you need to put plus or minus. So plus or minus the square root of 6, and plus or minus the square root of 9, which is a perfect square, so that comes out as plus or minus 3. So if you wanted to write these, you have a negative 3, a negative square root of 6, positive square root of 6, and a positive 3. Those are my 4 solutions. Okay, number 18 is a compound inequality. That means 2 inequality symbols in the same string or statement. So to solve this type, we usually try to isolate the variable in the middle if we can. So we're going to subtract 7 from all 3 sides. So that's going to make this negative 20 less than or equal to 2x less than 4. We're going to divide all 3 parts by 2 to get the x by itself. Make sure if you divide by a negative, you flip your inequality symbols, but we're dividing by positive 2. So this says this runs from negative 10 inclusively, because it has the equal to, up to almost 2. We're supposed to express our solution in interval notation. So remember, that would be a bracket, comma, negative 10, because we have a closed circle on negative 10, and we're going to be shading up to positive 2. But we're not including 2, so that's going to be a parentheses. Okay. For number 19, we're doing solve the inequality, and this is an absolute value inequality. So these break down into 2 main cases, and then there's 2 special cases. If you have an absolute value that is less than a positive number, so say 3, or an absolute value that is greater than or equal to, say, a positive number. Either one of these could have equal to. I'm just giving you both scenarios. These 2 are the cases you can solve. If you have an absolute value is less than a negative number, that is always going to be no solution. Because in this scenario, absolute value always comes out positive, and a positive should not be less than a negative. If you have an absolute value is greater than a negative number, that is all real numbers, because a positive value, which is what you get when you take an absolute value, is always greater than a negative value. So these two would be special cases. So these are the ones that if you have something to solve, you need to know how to set it up. So if I have this scenario, then we're saying the distance, our absolute value is from x, our argument inside, whatever this phrase is, needs to be less than 3. So imagine if you have a centered point, we don't want to go 3, we want to go 3 below it and 3 above it, but we don't want to go further than that. We want to keep our distance less than 3. So that means we're going to set our inside in between -3 and 3. We're staying centered close to our value, okay? If you're doing a greater than, you want your distance to get farther away. This is like saying, give me a bubble around myself where nobody stands, and then people can stand on either side of me. So this is two separate cases. So this would be one case where people can be 3 away from you and further down to -infinity. So we would say the inside of the absolute value is less than or equal to the negative case, or the inside of this absolute value can be on the right side of me and going to positive infinity. So we get a greater than or equal to case, which this looks just like your original inequality. The less than or equal to and the negative sign on this is saying we're heading completely in the opposite direction towards the negative infinity. Now, obviously, if there's something interesting inside your absolute value, like a negative in front of your x, you might end up flip-flopping which one is which when you divide, but you'll still get one heading in each direction. So when you have a less than, it's an and problem. It looks like an and where you have between two numbers. When you have a greater, you have an or situation. So we're going to be doing one of each of these. So this first one is isolated already, and it has a positive number on the right side. So this is less than a positive. It's the first case. So we set -3 less than or equal to the entire inside of the absolute value less than or equal to the +3. We're setting it between -3 and 3. So then we try to solve this. We're going to multiply all three sides by 4 to get rid of that denominator. So that's -12 less than or equal to 3 plus 2x less than or equal to +12. Subtract 3 from all the sides because we're still trying to isolate that x in the middle. So this would be -15 less than or equal to 2x less than or equal to 9. And then we're going to divide everything by the 2. So we're getting fractional answers. We will not turn these into decimals. We want to write this in interval notation. So it's brackets because of the equal to bar. It's -15 halves, comma, 9 halves, bracket. So everything between those would be shaded. Okay. Which, by the way, did one of these have us graph? I don't think any of them did. So let's look at solve the inequality of the second one. So this is the case where we have a greater, but we need to make sure it actually is correct to solve this, because sometimes they may throw a -3 in over here and you divide and you get a -7, and then it becomes that special case. So when we divide or isolate that absolute value first, that will then tell us how we're going to solve this. So this would be greater than 7. So it is a greater than, and it is a positive number. So we have two situations. We either want to go to the far left of -7, or we want to go to the far right of +7. Imagine that bubble around you, 7 feet on each side, and then you're going further away on each side. So we're going to add 5. So that would make this -2. Divide by +2, we get -1. We'll add 5 over here. That's 12. Divide by 2, we get 6. Now, and if you want to, sometimes drawing the picture on this one helps you write the interval notation. So we have -1, 0, 1, 2, 3, 4, 5, 6. We're saying less than -1, so that's a parentheses and shade to the left. Greater than 6, parentheses, shade to the right. So this is -infinity to -1, parentheses, and when you have a gap, we use the union symbol, that's the or, and then +6 to infinity. Using our parentheses because there's no equal to, and you always use parentheses on infinity. Okay, that leads us to number 21. This is the solving inequalities, and 21 and 22 are very similar. They have the same method that we're going to use for them. Anytime your inequality is a quadratic or higher, so polynomials that have a power of x squared or higher, or you have a rational inequality, which means you have an inequality where there's an x in your denominator. Those should all be evaluated much more carefully. There's not a nice, easy trick to solve them, usually without some analyzing. So we use something called a sign chart to help us figure out our answer. So the idea is to first get this into a place where we can factor it. So we're going to move over that 4, and that'll be negative 16. We're going to factor this into, that would be a positive 8 and a negative 2, multiplies to negative 16, but adds to positive 6. That would give me a value of negative 8 and positive 2 as places where I could equal 0. Now, we're not going to set this equal to 0 and solve and say, or less than 0 on both of them, because a lot of times people will do that. They will just say, let me set both less than 0 and solve. That is not true, because to be less than 0, you have to have the multiplication of both factors together. If this is negative and this is negative, they multiply together, they're going to make a positive, and that would no longer be less than 0. So what we do instead is we set up a sign chart where we list our values that made us equal 0 from least to greatest. So negative 8 and positive 2. We look here to see if these are going to be opened or closed circles. So they're both open. So this is going to be the interval negative infinity to negative 8. That's what's to the left of negative 8. This is the interval negative 8 to positive 2. And this is the interval from 2 to infinity. And these are both open circles if you want to draw that in. Okay, we're going to pick a test value in each region. The reason we do that is so we know if the region has a true overall answer or a false answer. Does it give us less than 0, or does it give us greater than 0? And you have to pick a number in the interval you listed, or it doesn't tell you anything. So this is negative 10, because negative 10 is smaller than negative 8. Anytime my sign changes, I try to use 0 if I can, and something bigger than 2, I can use 4. Now, your numbers could be completely different than mine, but as long as they're in the correct interval, then it should still give you the same result. And then I usually list my factors that were on my left side. So we usually always want this on the left side and the 0 on the right side when we're setting these up, so it reads more left to right, because that's the way our brains want to process that information. And then we're trying to make sure that whenever we multiply these two guys together, we get less than 0. So you could write the actual numbers here if you want, but it's not necessary. You really just need to know, if I plug in negative 10 into both of these factors, does the answer come out positive or negative? And then if I multiply those two answers together, is it positive or negative? So negative 10 plus 8 is a negative. Negative 10 minus 2 is a negative. A negative times a negative is a positive. 0 plus 8 is a positive 8. 0 minus 2 is a negative 2. Positive times negative is negative. 4 plus 8 is positive 12. 4 minus 2 is positive 2. Positive times positive is positive. The choice that you make, because we actually have solved both less than this and greater than this by doing the sign chart, but we wanted specifically less than 0. So we're looking for any region that has an overall negative sign. So the only region that has it is the middle region. So the solution to this is any value on the number line between negative 8 and 2. Now it does say to graph the solution set on this one. So again, I'm not going to write every number in, but if you had, say here's 0, and here's 2, we would be shading everything in the middle with parentheses. Okay. All right, so let's look at number 22. Similar type setup, except this time it's the rational inequality. Now these are always a little bit more involved, just getting them ready to solve. You have to get everything on one side, so you have 0 on the right side, and you have to get a common denominator. So I'm going to move over that 4. Please do not be tempted to just cross multiply here, because that will not give you all the possibilities, and sometimes the signs don't work out the way you want them to. We really need to analyze this by each individual factor. So if I want to get a common denominator, I need to multiply the top and bottom of this second fraction by the 4x plus 7. So then when we work this out, we have x minus 2. Be careful here, make sure you're distributing that negative. We have negative 16x and negative 28 all over 4x plus 7 less than or equal to 0. We then combine like terms on top. This is negative 15x minus 30 over 4x plus 7 less than or equal to 0. You want to find what makes both of these equal 0. So you may have to solve it onto the side just to figure out what those are. So this is negative 15x equals 30, so x equals negative 2. The bottom one's a little easier. It's negative 7 over 4, except we really don't want to equal that. That would make us divide by 0. That's undefined, but it is still a value where we would have either a 0 or an undefined. We consider both of those when we break up our number line. So if it's a fractional one, you need to know anywhere the numerator is equal to 0, which is x equals negative 2, and anywhere our denominator is undefined, which would be the negative 7/4. And then here's the thing about this. Even though this is equal to, we can't put an open circle or a closed circle on both of these. Your denominator will always be open every single time because it's an undefined value. The numerator will follow whatever this symbol says. So since it's a equal to, sorry, I couldn't speak, it will be a closed circle or a bracket. So then we put our numbers here. Now you do need to think about this. That is less than negative 2 because negative 8 divided by 4 would be negative 2. So these are pretty close to each other. So negative 2 has a closed circle, but negative 7/8 or negative 7/4 is an open circle since we don't want to divide by that. So this is the interval negative infinity to negative 2 with a bracket. This is bracket negative 2 to negative 7/4 with a parentheses, and negative 7/4 to positive infinity. Okay, we're going to set up our test values for each region. So something smaller than negative 2, I could use negative 3. You might want to know exactly what 7 divided by 4 is because we're going to have to use a decimal. That would be negative 1.75. So negative 1.8 or 1.9, either one of those would work for being in between those two. And then this 0 is bigger than that negative number, so that's easy to plug in. I would not pull the negative 15 out, and I'll explain why. I would leave it in my factor because when you're working this out, if you leave the negative 15 out of your list of factors over here, every single final sign at the bottom will be wrong because negative times anything changes a sign. So I always leave it in that binomial so that I don't miss that negative sign. So then we look at this. So negative 3 times negative 15 would be positive 45. Minus 30 would be a positive. Negative 12, when you do 4 times negative 3, plus 7, that's going to be a negative. Positive times negative is negative. And you may want your calculator for the middle one. So 15 negative times 1.9 negative is 28.5 minus 30 is going to be negative 1.5. So this gives me a negative. Negative 1.9 times 4 is a negative 7.6, plus 7 is still going to be a negative. So negative times negative is positive. 0 is a little easier. That would make negative 30 and positive 7. So negative times positive is negative. Now we want less than or equal to 0 again, so we are still looking for negatives, but this time we have 2 negative answers. So that means we're going to have a union because there's 2 separate regions. So negative infinity to negative 2 with a bracket, and then there's a gap, and then parentheses negative 7/4 to positive infinity. Okay, we just have a few more examples to get through. Sorry, that was trying to drag down with that. So that's negative 7/4. Okay, so the number 23 says find all points on the y-axis that are a distance of 4 from the point 3, 2. Now, when we think about distance and we hear the word distance, we need to think about our distance formula. So d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. This is really Pythagorean theorem if you look at the picture of how the two ordered pairs and the distance between them works. If you want, you can rewrite this as d squared, and it's a little easier to do this instead of dealing with the square root. Especially for these types of problems, you can write it like this where it looks more like Pythagorean theorem. Now, we've been told that we want to find all points on the y-axis. So points on the y-axis have a specific format. They're y-intercepts. So that means they are a 0 for x and an unknown variable, which we don't know yet because we're trying to find them, for y. So 0 comma number is a y-intercept. We want our distance to be 4, so d equals 4, and our second point is 3, 2. So second point is 3, 2. Okay, so we have 2 points, 2 ordered pairs, and we have a distance. So we're going to plug this in. So 4 squared. Now, I usually choose to make sure that y comes first when I have my parentheses. So I'm going to do 0 minus 3, so I would also do y minus 2. So 0 minus 3 squared is the subtraction of my x's, plus the y minus 2 squared. 4 squared is 16. Negative 3 squared would then be positive 9, plus y minus 2 squared. Subtract the 9 over, we get a 7. Now, this is where a lot of people will go wrong in this problem. They try foiling this out and then making life harder. You can use the square root property that says as long as this is something squared equals a number, we can take the square root of both sides, as long as we remember to put that plus or minus. So this is y minus 2 equals plus or minus the square root of 7, just rewriting it a little bit clearer. Add the 2 over. Now, these are y-intercepts, so that means that's 2 separate ordered pairs. 0, 2 minus the square root of 7. Notice that's a y-intercept. And 0, 2 plus the square root of 7. So those are the 2 y-intercepts that are a distance of 4 from the point 3, 2. Okay, so we want to look at number 24. This is a standard 023 and 043 question. If you took those classes before 136, the question here is, can we find the equation of a line if we know 2 ordered pairs? And then write our final answer in slope-intercept. So the first thing is you have to have slope to be able to write the equation of a line. So we're going to use the formula that says m, which is the slope, is equal to the change in y over the change in x, or rise over run. Remember, you can label these. These both come from the first ordered pair. These 2 come from the second ordered pair. So that would be 5 minus a negative 2 over negative 3 minus a negative 5. 5 plus 2 is 7. Negative 3 plus 5 would be 2. So my slope is 7/2. And then we usually teach point slope as a way to get this into equation format, which is really just the slope formula with this x2 minus x1 multiplied over to the other side. And then we just say y and x instead of x2 and y2. Because when we want the equation, we want the variables in there. So you pick one of the points. It doesn't really matter which one. So why don't we use the negative 5 and the negative 2? So y minus a negative 2, so that's going to end up being plus 2, equals 7/2 x minus a negative 5, so that'd be plus 5. If you don't want to distribute a fraction, you can distribute just the, you can multiply both sides by the denominator here. That will clear out the fraction on the right side for you to be able to solve a little quicker. So this is 2y plus 4. That would just make the 7 get distributed, so 7x plus 35. Subtract the 4 over, that would be 31. Divide everything by 2, so 7/2 x plus 31 over 2. And that is now in y equals mx plus b, which is slope-intercept form. Okay, number 25 is the difference quotient. It's this function evaluation here that we're trying to work through, and they've given us a function. So the first evaluation on the numerator is that we're going to replace the variable x with the binomial x plus h. So when we write our difference quotient down here, we'll have 3 parentheses squared plus 7, and that first evaluation is to make that x plus h instead of just x, minus the function, because negative f of x just means distribute a negative sign to the function, all over the variable h. So we're just plugging this into the formula. Now in the numerator, you'll probably want to write that x plus h times x plus h, so you can work it out. Also, if you'd had an x in your 7, like if this had been 7x, you would have also had to put an x plus h there, because anywhere the x went, that's where we put that x plus h. Distribute this as negative 3x minus 7 all over h. If we FOIL out the binomial, we'll get an x squared plus a 2xh, because there's like terms in the middle, plus an h squared. Bring everything else over. all over h. Distribute the 3, so that's going to be 3x squared plus 6xh plus 3h squared minus 7 minus 3x, or sorry, plus 7 minus 3x squared minus 7 all over h. The plus 7 and minus 7 cancel out, and so does the negative x squared and the positive 3x squared. So those two are matches as well. So this reduces down to just 6xh plus 3h squared all over h. And then when we reduce out the h, because each factor on top has an h, this would just be 6x plus 3h. Now that's going to be a really big topic if you're going on to calculus, so this is important, this difference quotient. All right, the last example for the midterm review, we're looking at the domain using interval notation of the following functions. So the problem with functions is that there's 5 main types that we talk about in the first half of the class. We talk about polynomials, which have no domain restrictions naturally. We talk about absolute value functions, which again, you can plug any number that's on the number line into those, it's fine. We talk about odd roots, which are also fine because you can have a negative under a cubed root or a positive under a cubed root and still get a real number. Where we get into trouble is anytime you have an x in a denominator that makes you divide by 0, or if you have a radical that is even because they cannot be imaginary solutions. So we have a kind of a hybrid problem in these, that they have both of those situations. They're both even radicals and they have x's in their denominator that possibly could make us divide by 0. So we need to consider what are the situations for both of these. Now, to keep this from being imaginary, you need to make sure it stays greater than or equal to 0. Square root of 0 is okay as long as it's on top, and greater than 0 will be a real number as well. So we want to add over that 3 and divide by the 8. So no matter what, I can never have an answer that is less than 3/8. So you could go ahead and write 3/8 is the smallest that this can ever get for my domain. Nothing else should work. Now what's going to be the rest of it, we're going to have to look at the denominator. So if we factor this denominator, this is x minus 10 and x plus 3. So if we solve both of those, that would mean that we can't be negative 3 or positive 10. Now negative 3 has already been thrown out because it is less than 3/8, because this top part said you cannot have anything less than 3/8. So we don't have to worry about negative 3. But 10 is bigger than 3/8. So we need to go and skip the number 10 in our interval notation for our domain. To skip a single number, you end one side of it with a parenthesis. So this is like 9.9999999. Then we start a parenthesis on the other side where this is like 10.000001. So obviously we don't know the exact decimals, but we're getting as close to 10 as we can on both sides without using the number 10. So this is the domain for this first one. So we didn't have to include both of the numbers from the denominator since one was already excluded in the first condition on the numerator. Let's look at the same issue for part B. We have to make sure that that top part has that even radical that stays greater than or equal to 0. So let's say x plus 3 has to be greater than or equal to 0, so x has to be greater than or equal to negative 3. So I already know in my domain I can go down here and say I can never go below negative 3. The denominator has, let's see, minus 6 and minus 3 as the two factors. So that means we cannot plug in a positive 3 or a positive 6. Now, both of those numbers are bigger than negative 3. So we need to make sure we exclude both of them. And you want to exclude them from least to greatest. So negative 3 to 3, where we can't use the number 3. Then you go from the smaller one to the next larger one. So from 3 to 6. And then finally from 6 to infinity. So there's no sign chart involved here. You're just saying all of these values are from greater than or equal to negative 3 are acceptable except 3 and 6. And in this one we said all values greater than 3/8 are acceptable except 10, since 10 also was in that acceptable region, but it was a restriction from the denominator. Okay, hopefully this was helpful in studying for your midterm. I hope everyone does well.